Hello, my name is Fabrizio Bertoglio, and today am doing a presentation about the challenges that React Native developers experience when building mobile apps with React Native, and how we can learn from these challenges and improve the platform. My experience with React Native, from the challenges I had during while building my own mobile app, SurfCheck. The app took around 1 year to build, and I had the chance of experiencing several difficulties with React Native. So the number one difficulty is the development environment, which sometimes would break and have some issues. Number two issue would be installing the native dependencies, as I was not using Expo, I was using React Native, and configuring and installing dependency would take a big quantity of my time. Unknown limitations from React Native ecosystem, not knowing sometimes functionalities that trying to build the functionalities that are relatively hard to build with React Native. For example, in 2019 I tried to build a pinch to zoom functionality to allow users to to take videos and zoom with a pinch gesture, which is was relatively difficult to build in 2019, while in 2020 new pull request has been merged to React Native Camera, and now it's possible to do it. It's really easy to build. Upgrading React Native from 0.59 to 0.62 was another big challenge. Took a lot of my time, and also again issues. I experienced issues with flat list, with callbacks on end reach not being triggered correctly, Zeta index not working as I expected it to be working in CSS. And then also complexity of the functionalities. For example, I used the React Native maps to display big number of points of surf spots on the map, but when zooming out and using custom images as pins instead of the default pins provided by the React Native Maps library, I would experience issues with performance issues. The next slide is focusing on how this experience that I had personally building over 1 year mobile app are also shared by other developers and in our community, and how trying to maintain writing pull requests and maintaining React Native. I went through or read several of these issues, and had the opportunity to read also the opinions of other developers and their view on React Native, on the issues that they were affecting them, and reading their opinion. And of this I came out with 4 points. For example, the first point is the style prop. So the style prop, which should work as a CSS. The developers would sometimes be disorientated by the fact that the style prop would not exactly work like CSS, and there's a couple of issues I refer to here. For example, issue 27333 and 25441, which are mostly issues where for example, the user was trying to assigning a touch handler to a view or a touchable opacity, and the parent has but is contained in an absolute positioned container, which has no height and no width, and for this reason the touch is not triggered, because Android and JavaScript and HTML are very different APIs, and it is relatively challenging to have a style prop that acts exactly like CSS in React Native. there are some limitations to this, and that sometimes will make developers be really disoriented, and not because they cannot understand the underlying, they don't know maybe the underlying Android API which causes these issues. Then the same issues is with Zeta index. So the Android API which is behind the Zeta index is different from the API which is behind the Zeta index we use in HTML and CSS. And for this reason, the index behaves differently and can be time consuming, can take a time for the user to guess the correct behavior. Then the third point is performance limitation connected to the React Native bridge. Also here there's an popular open issue in the React Native repository about text input becoming really slow when the user types very fast, because the on-change events will bubble and reach some sort of limitations in the React Native bridge. So then also limitations from the React Native libraries. It's hard to understand before installing a library what actually the library can do and what are the limitations, and sometimes it cannot fulfill our needs. So then getting started to solve issues with React Native is relatively easy. The first step is we need to install React Native from source and add it to an example application as a dependency. There's a guide in Facebook React Native wiki called Building from Source, which will guide us through the installation of all the dependencies, configuration of the environment variables, and then on how to add the React Android project to our example applications. Once we added the React Android project to our example application, we will be able to see in the node modules directory there's a folder called the React Native, and inside that folder called React Native we can see the React Android project, we can see the Java libraries, and we can debug Java, and we can use the debugging tools I will talk to in the next point. The second important point is creating a minimum reproducible example which will recreate the issue we have in React Native without any additional source code or without any additional functionality that is not essential for creating the issue. Then the third point is debugging, is using the different tools we have available to collect information that help us understand what is the issues with React Native. So the issue could be connected to the JavaScript libraries, including in React Native, and we can use the JavaScript Debugger tools, Flipper, React Native Debugger, or just a simple console.log to log in the console the output of the different variables, functions, and or to understand when some functions are invoked, and to understand how the code works without having to inspect every line or reading every function. And then if the issue is not connected to JavaScript, or if we need an additional level of detail, then we can read the Java. In the case the issue is for an Android issue, we can read the Java libraries and we can debug those React Native Java libraries with Android Studio. We can set a breakpoint at a certain line of the Java code, or we can and then we can run the emulator, reproduce the example, reproduce the issues. The Android Studio will stop at that specific line of code, and we can evaluate the statement, see the variables and the different functions and methods, so the value they return, and use all this information to try to understand which line of code is actually causing this issue, and which line should be fixed to fix this issue. The third point is really important. I think the debugging tool is also using logging the console, which is very fast. Doesn't require us to stop in the program execution. It will be more lighter, and the resource affect lighter our performance in our computer, and we can both log JavaScript and Java at the same time to see both sides what they're doing, and it will help us to understand how the source code works. And the most important point, I think, is the fourth point. Most of the issues are very simple, and they're easy to solve. Most of the issues, they just don't they lack a reproducible example, or the reproducible example is not a minimum reproducible example. So there's many functionalities included in that example that will distract us from the real reason. And the most of these issues, most of the Java React Native libraries are based on the Android API, which rarely have problems. So we just need to understand exactly which part of React Native is not working, and then fix it and find a simple solution for that problem. A good way to start with React Native is starting with a library, with a native library, which will be easier than contributing to React Native. An example here, I'm talking about React Native Camera, as I started with React Native Camera, contributing to React Native Camera before React Native. And React Native Camera will be easier to contribute to a project like React Native Camera or another sensor API, another native API, as the library is smaller, has a lower level of complexity, is easier to, there's a fewer number of files there. It's easier to understand how the library is built, and it's easy to memorize the source code. Additionally, working with React Native Camera, for me, it was a great opportunity. I had the chance to work with the React Native bridge, to use the React Native bridge, and which is relatively complex if you read the React Native source code, but is relatively simple when you are using the API as a third party, the React Native API as a third party. And I think it's very important to understand the connection between JavaScript and the native API, and this contributing to React Native Camera for me was a great opportunity to get to understand how third-party libraries are built on top of React Native. Additionally, it's an opportunity to get familiar with the React Native source code and start learning about Android and iOS API. We display the output in the terminal from the QR code scanning in React Native Camera, and then we can open the debugger, the Android Studio debugger, and open that barcode scanner async task file and set a breakpoint in the process. We display the data width, the variables data width and data height, which define the width and height of the image. As I can display in the README of my pull request, we display, I made some screenshots of the images, includes ruler to display the dimensions in pixels. The image has 1440 and 1080 of width multiplied height. We are scanning in a horizontal mode, and we can display the values of the pixels in the rulers, and also we can display them in Android Studio. In the debugger, we are using the planar YUV luminance and source from ZSync constructor, which takes several parameters. The first parameter is the YUV data, the image in format YUV, and then it takes data width and data height of the image, and takes in left and top, which is the top left corner in this case, the starting point that we use to crop the image. So we define, we pass those information to the constructor here at display in the debugger. We pass data width, data height of the image, and then we pass the mrect.left, mrect.top, which represent the top left corner, in this case in horizontal, when scanning horizontally. As I'm not spinning the image, the data, I'm not spinning it and converting it to portrait. We're scanning it. We start from the top left corner, as displayed in the image, in the video. And then we can see in the ruler that so the left is the position of the top left corner from the left side, which is 250, and the same is the output we get from when evaluating the variable. Now we display the result, the mrect.top, which is 300, and is the distance between of the top left corner from the left side, as we can display in the ruler, from the top, and then we pass the width and the height of the image. So the testing library will use these 4 parameters, left, top, width, and height, to define the top left corner where to start cropping, and then we'll draw a rectangle with width 950 and height 600. Around our barcode, and we will use this to restrict the area, use it to decode the barcode, which will increase the speed and it will optimize the process for decoding. We then create a binary bitmap, an image, and we pass this bitmap. We execute the decoding. As we can see, the result will be the result of the text we display is the same text we display in the terminal, and this is a successful decoding process using the cropping functionality of the Zscaling library. The next bug is next issue from React Native. Is a simple user interface bug. As we can see on the right, the phone has a yellow view background, a view with a yellow background, which has a keyboard avoiding view, and the status bar on top is set to translucent. So the yellow view will display under the translucent status bar. For this reason, in this case, the yellow view has additional height of around 50 pixels, which is the height of the status bar. And when we display the keyboard, when we display the keyboard, a KeyboardDid show event will be sent, and will send a payload of few informations to send to JavaScript, to React-Native JavaScript, the height and the coordinates of the available visible view. When the keyboard hides, it will show a white area in the bottom, and this is just because this is the reason of this is because the view height. So mVisible view area.height does not include the height of the status bar. While simple fix for this is just using mLastHeight instead of mVisible area view height, mVisible view area.height, and replacing this with the correct variable will fix the issue. So it's very simple to solve, and it's also very easy to understand this, as it's very visual, and this is the characteristic of many of the issues we have in React Native. They're easy to understand, as they are user interface issues. We can display the output inside the phone. The next issue is numeric font weight. So numeric font weight, you can see on the left that the numeric font weight from 100 to 600 to 900 does not work. It does not have any effect, and this is because there's a new method called Typeface.create, which accepts additional parameter for numeric weight, and this is only available since API 28. So also this is another easy fix. We check for the version that is API. If it's higher or equal than API 28, then we use this Typeface.create, and we pass the numeric weight so that it can display like in the right side of the screen with different level of weight. Text input inside a scroll view. So the next issue also here, also very simple solution. So it's at least in some situation it's not possible to scroll a text input when it's inside a scroll view, because the onTouch event will delegate to the parent view, and this is mostly caused by the can scroll horizontally and can scroll vertically methods from the Android API, which do not really work with Gravity Center. So it's very easy also here solution. We just disable Gravity Center when the text is being edited. When the cursor, we touch inside the text input, we set it to gravity left, and then this issue from the Android API can scroll horizontally method that does not tell us when we finish scrolling a text input is not. We don't have this issue, so it's a really simple solution. The next slide, an additional issue we have in Android source code, a runtime error called will say Android graphics drawable constant state new drawable on a null object reference, and without going in the details of this issue, this is caused by the text input default drawable we are using with the React Native Android theme app compact. This Android theme we are using when we generate new projects with React Yarn, React Native init, always some project. When we run this command, by default the React Native will use their template. The React Native CLI in this case will use their template to generate a project, and this template uses the Android theme app compact. Android theme app compact provides a default drawable. So the drawable is background, like an image for background for the text input, and this text input drawable causes this issue. So the simple solution is just change the template, so that the template uses a custom drawable instead of the default drawable, and this drawable is exactly the same as the previous drawable, but does not include those elements that trigger the runtime. So to reach the conclusions are React Native issues right now. In the issues we have open in our open source project are many of these issues are probably relatively easy to solve, and there's no need for Java or Objective-C knowledge to solve those problems. There's no need for Android or iOS experience to solve those problems. We just need to set up follow this the guidelines included in the React Native wiki, and then that I referenced from this slide from this presentation. Set up your development environment, use all the tools that will help you provide the information to solve those problems, and then the steps will be 4. So the first step will be reproduce the bug. The second step will be create a minimum reproducible example. Remove any part of functionalities that are irrelevant for that issue and may make the problem harder to understand and to solve. then finding the React native source code responsible for this issue, causing this issue. So research inside the project for pull requests that reference that had to do that can provide some information on how that functionality works. Searching for just simply searching for in the open source project for those keywords and finding and then debugging those functionalities. And then once we found the source code responsible, we probably have to understand the Android API, which is being used by the iOS or the iPhone API, which is used by the specific functionality, and understanding that and try to implement a solution.